Alright, so today we're going to be graphing sine, cosine, and tangent functions. So let's start with sine and cosine functions. The parent functions for sine and cosine are y equals sine x and y equals cosine x, and they look like this. These are cofunctions, so they're going to look very similar. As you can see, they're pretty much the same except for where they start. Sine will typically start at the origin and go up first, while cosine starts up here and goes down first. Now, if we really want to understand these functions, we'll have to define a few terms first. Specifically, the amplitude, period, and phase shift or vertical shift. The amplitude is just the distance from the middle of the graph and either up to the highest point or down to the lowest point. So as we can see here, the amplitude is 1. The period is the horizontal distance that it takes for this graph to start repeating itself. As we can see here, everything after this point is just a repetition. So here, the period is 2 pi. A shift is just what we would call a translation. A phase shift occurs when the graph moves left or right, and a vertical shift occurs when the graph moves up or down. The graph itself isn't changing, it's just shifting in location. Now remember those parent functions I showed you earlier? Well, we can take the equation for those parent functions and edit it a bit so that we can accommodate for when the amplitude, period, and phase shift are more complicated. So when you're given something that's formatted like one of those, you can use it to find the amplitude, period, and phase or vertical shift. A is how you find the amplitude. Your amplitude will be the absolute value of A. B is how you find the period. Your period will equal to 2 pi divided by B. C is how you find the phase shift. Your phase shift will equal to C divided by B. D is going to be your vertical shift. Okay, so now you know all that stuff, but let's backtrack to something a bit more familiar. We still need to find the domain and range of these functions. Luckily, that's super easy. The range is going to be whatever your highest and lowest points are. So here, it'll be -1 to 1. The domain, of course, is just going to be -infinity to +infinity. Now, let's move on to tangent functions. The parent function for tangent is y equals tan x, and it looks like this. As you can see, it's periodic just like sine and cosine, but the period of a tangential function will be pi. Unlike sine and cosine, a tangent function will have asymptotes, which I've got here in blue. A tangent function's asymptotes will be at x equals p divided by 2 plus pn, where p is the period and n is an integer. Because of the asymptotes, our domain will be a little funky. Your domain for tangent functions will be all real numbers except for the asymptotes. So, for the parent, all real numbers except for pi over 2 plus pi n. The range, as you might have guessed, is just going to be -infinity to +infinity. This means that tangential functions don't have an amplitude. Now, just like with our sine and cosine functions, we can expand this equation to accommodate for more complicated functions. The only thing of note here is the period, which is once again found using b, although this time your period will equal pi divided by b. Now that we know how to find all that important stuff, we need to know how to label the x and y axis, because it is different than how you usually would. The y-axis is pretty easy. You'll just be labeling it with whatever points best express your y values. How you label the x-axis will mostly depend on what form your x values will be in. They're either going to end up using pi or whole integers. It just depends on how it works out with your given period. If your period involves pi, then the x-axis is labeled with values from the unit circle. If your period is a whole integer, then your x-axis will also use whole integers. So the last thing you need to know how to do is choose which points to plot. Luckily, that's really easy to do. We'll choose our x values by doing a little trick with the period of our function. We'll take the period and divide it by 4 to get our first point. Then, we add that first point to our period divided by 4 again to get our second point. Then add the second point to period divided by 4 to get our third point, and so on and so forth. We can continue this pattern to get all of our points, but honestly, you only really need to find 2. Since the graph repeats the same pattern, we can extrapolate what its following points will be just based on its first 2. Then, we just plug those x values into the function to get our y values. Now, let's go ahead and put this all together. So for this first example, let's start by finding the amplitude, period, and phase shift or vertical shift. The amplitude will be 3/4. Since our a is negative, we know that the graph will start out from -3/4 and go up. Our period will be 2 pi divided by 2, which equals 2 pi times 2 over pi, which equals to 4. And lastly, we know there isn't a phase shift or a vertical shift since we don't have a c or a d to deal with. Now we can go ahead and label our graph. The y-axis is easy. We'll just label it with regular whole integers. For the x-axis, let's take our period and divide it by 4 for our first point. We'll see that that'll be 1. And since that's a whole integer, we know that our x-axis will be labeled with whole integers as well. Our next point is just our first one, plus period divided by 4, which of course is 1 plus 1, which makes our second point 2. For our third point, we'll take the second point and add it to 1, we'll get 3, and for our final point, we'll take the third point and add it to 1 to get 4. And now we don't really need to label anything more than that since we've already reached our period. And with that, we have found the x values that we're going to be using to plot our points on our graph. Now, we could plug those into the function to get our y values, but since this is cosine, you don't really have to. For sine and cosine, you can just follow the pattern of the function. Since we already figured out that the graph starts at -3/4, we know that the next point will be at y equals 0. The one after that will be at +3/4. Then we go back down to y equals 0, then finally back down to -3/4. Now we just connect the dots, and you'll get something that looks a little like this. And from this we can see that we have a domain of -infinity to +infinity, and a range of -3/4 to +3/4. For this second example, let's start by finding the period, vertical asymptotes, and phase shift or vertical shift. The period will be pi over 2. Our vertical asymptotes will be at x equals pi over 4 plus pi n over 2. We're going to want to choose 2 of those vertical asymptotes so we can plot this function, so I went ahead and plugged in 0 to get a vertical asymptote of pi over 4, and since we know that tangent is periodic, we know that -pi over 4 is a vertical asymptote as well. And we don't have a phase shift, but we do have a vertical shift of 1. Now we can go ahead and label our graph. Once again, the y-axis is easy, we'll just label with regular whole integers. For the x-axis, let's take some unit circle values since we know we're going to be working with pi. When you have any kind of shift, it's easier to just plot the function without the shift first, and then shift it up or down or left or right later. So here, we're just going to be plotting y equals tan of 2x, and then we'll shift it up by a value of 1 afterwards. You're only really going to need to plot 3 points on each side of each vertical asymptote. The first one is easy. It's just going to be halfway between any 2 vertical asymptotes. In this case, 0, 0. Then we find the other 2 by plugging in some x values. I chose pi over 6 and -pi over 6 just because they were easy, and got pi over 6, comma, square root of 3, and -pi over 6, comma, negative square root of 3, respectively. Now we just take these points, shift them all up by 1, remember that's our vertical shift, and we are good to go. We just connect the dots and you'll get something that looks a little like this. And from there we can see that we have a domain of all real numbers except for pi over 4 plus pi n over 2, and a range of -infinity to +infinity. So yeah, I hope that was helpful. Bye.